Hello and welcome. This is a lesson on storms. Get ready to learn. We're going to look at weather maps and different kinds of storms. Did you know? A storm is any kind of severe weather like rain, snow, or thunderstorm. Meteorologists, people that study weather, use weather data to predict storms. Why is this important? Well, the weather is always changing and storms can be dangerous. Here we got the east coast of the United States, Florida down here, and one very large storm. This is a hurricane, and they can be predicted as to where they're going to go and how they're going to move, and warnings issued. What's important to know about storms? Well, here's how they come about. Storms happen when water vapor condenses at a front. A front is when warm air meets cold air. They have different densities, different amount of water they can hold, different temperatures. When they meet, it's called a front. Water condenses from water vapor into droplets and drops. So water vapor, which is invisible, condenses. In other words, it goes from a gas to a liquid into droplets and drops. They condense on something called a piece of dust or a small particle called a condensation nucleus. In other words, condensation means it condenses, nucleus meaning it's in the center. So at the center of every bit of snowflake, every droplet or drop, there is a condensation nucleus or a piece of dust. Now, when they're large enough, they fall as some kind of water, some kind of precipitation, rain, snow, or sleet. Now, let's go through some of these. Rain. Frozen precipitation melts and reaches the ground as rain. So it's always, if you can see it, it's solid. Because remember, water vapor is clear, so if condensed, it's in a cloud. And it's now solid. So as it falls, the warm air melts it and you get rain. If it falls, it melts and then freezes again. You get freezing rain. So you got frozen precipitation, melts in warmer air, and then the rain falls and freezes on a cold surface. So you have freezing rain. So it's rain that then freezes. If it flows through the warm air and then freezes before it hits the ground, frozen precipitation melts in shallow warm air. Here it is melting. But then refreezes in the sleet before reaching the surface. They come down as little bits of ice. Sometimes they bounce and get layered. We call that hail, which is not in here, but hail is just, it repeats and goes in a cycle here and gets layers and layers. And then we have snow. Snow never melts. It just falls through the cold air and reaches the surface. So we've got rain, freezing rain, sleet, and snow, and it depends on the layers of air that it falls through. That's how storms are constructed. Now, Storms can be predicted. Computers take remote sensing data and make a map either from satellites or weather stations, or there are actual people that have a box in their backyard. They record the temperature and barometric pressure and call it into a computer. The map shows pressures. They're in isobars. Iso meaning the same and bars meaning barometric pressure. So we have map showing isobars. Here's an isobar. Oh, sorry, here is an isobar. Any place along this line is the same barometric pressure. We have wind direction. Let me show you one of those. Right here. Tells us cloud cover, wind direction, and speed. Temperatures, they're just written on. And fronts. These are the fronts. That's where a high pressure and a low pressure are meeting. So knowing all this, we can predict storms. And if we can predict them, we can issue warnings that there are storms coming up. There's low pressure area, there's a high pressure area, there's an isobar. Now, got a couple different kinds of cloud types. Cirrus clouds. These form ice crystals and are thin and feathery. It's a sign that wet weather is coming. Not right away, but it is on the way. We have stratus clouds. They form low in the troposphere in layers that spread out horizontally. Stratus clouds that produce precipitation are called nimbostratus. So we can talk about the kinds of clouds. Stratus clouds, same base word as striated or layers. So you have stratus clouds. Then you have cumulus clouds. They're white and puffy. They may grow very tall as fair weather clouds. Now, when they produce rain, they are then cumulonimbus. Nimbus meaning producing rain. So these are cumulus clouds that produce rain. Now, you've heard of hurricanes, typhoons, or cyclones. It's the same type of storm. They're large weather systems that form over wet water. It depends on where they are on the planet, what ocean they formed over, whether they're a hurricane, a typhoon, or a cyclone. The most damage comes from a large quantity of water and high winds. This is the state of Florida here, and you can see how big this storm is. So you've got damage coming from high amount of water. This is all clouds, and that's going to dump water, and also high winds. So you've got a storm surge. You've got, in other words, the wind is pushing the water towards the land, just like blowing on a soda with a straw. And then you've got all the water that's up in the atmosphere that's going to come down on the land. In the center is a low pressure area called the eye. Now this is spinning, and it's trying to spin. Let me draw some. This is spinning. So it wants to shoot the clouds out. And because of that, in the center is an area of low pressure. That's called the eye. Then we have a definition on the of the category of hurricane level, and it's basically got to do with how fast the speed of the wind. And these are sustained wind speeds. In other words, it's not like a gust of wind. These are winds at 111 to 130 miles an hour all the time. So, a tropical storm becomes a hurricane when it goes above 74 miles an hour wind sustained. Tornadoes. Tornadoes are small, local high winds that formed over land. Most damage is caused by high winds and sometimes hail because of the type of clouds that are formed. But you can see this, like the center of a hurricane, it's a spinning area of low pressure. But they form over land, not over water. There, of course, is another scale so that we can talk about how severe they are. And here's the estimated wind speeds. They're way beyond hurricane, but yet they're very local, maybe a mile wide, as opposed to 300, 400, 500 miles. So they're small and they're local. It could pick up a house and yet the house next to it is untouched. Very, very hard to predict. Thunderstorms. They're produced by cumulonimbus cloud with gusty winds, heavy rain, and sometimes hail. Remember, cumulus clouds that produce rain. Charges build up in the clouds and then strike to other clouds or ground as lightning. Here's a strike to ground from the buildup of charges in the clouds. But most of the lightning is between clouds. Now, lightning. Charges build up in clouds and then strike other clouds or the ground. They're trying to balance out the electrical charge in the cloud. Now, how did it get there? Same way that you have a charge buildup when you rub a balloon against your sweater. Electrostatic charge. Most lightning is between clouds. And then lightning superheats the air. It's very hot. And when the air comes back together, you hear something called thunder, a loud bang. Now, if you see the lightning and then count 1, 2, 3, 4, 5, and then you hear the thunder, because of the difference in time that you see something and you hear it, because of the different speed of sound versus the speed of light, 5-second difference between the lightning and the thunder means that it's about 1 mile away. I'll give you some idea about how far that lightning strike was. So why is this important? The weather is always changing. Storms can be dangerous, and storms can be predicted and warnings issued. Here's your lesson on storms.